Hey guys, I'm Lakshya and let's start with this. The second question in mathematical induction, guys. Here you have shown that 1 cube plus 2 cube plus 3 cube plus goes on till n cube, which is equal to n square into n plus 1 whole square by 4. So there again got 1 cube plus 2 cube plus 3 cube plus n cube, which is equal to n square into n plus 1 whole square by 4. Now guys, what you do is here coming back to this, where as we now coming back to this mathematical induction, where mathematical induction we will be having three cases to solve. Okay, we will be having 3 cases to solve. As firstly, we must imagine where n equal to, where n belongs to natural number, n belongs to capital N means natural number. Okay, so that's the rule that we have. So now what you do is, guys, we must show that LHS side which is equal to RHS side. Okay, we must show that LHS side should be equal to RHS side. So what you do firstly, here you have where, okay, now firstly as I have said, we have 3 cases. So let's go for the first case. If n equal to 1, because I am considering n equal to 1, as here I have said what n belongs to natural number, right? N belongs to natural number, right? So that's what I have considered n equal to 1. So this becomes what? 1 cube plus 2 cube plus 3 cube, which goes on till n cube. Instead of n, here I am going to write n cube, but what you do? You write 1 cube. Okay, instead of n, what I have said, n value n equal to 1, right? So that's what I have written 1 over there. Okay, instead of n, what I have written 1, which is equal to, here you have n square, and instead of n, what you do? You write 1. Okay, so 1 square into n plus 1 whole square. N value is what? 1 plus 1 whole square by how much? 4. Okay. 1 square into 1 plus 1 whole square by 4. This is the given one, guys, that we got. Now what you do? You equate LHS side equal to RHS side. As here you have what? Where n is the term, nth term, the first term. Okay, n equal to 1. So the first term is 1 cube. So guys, here coming back to this LHS side, where LHS side value will be what? Here you got what? 1 cube. So LHS side value will be what? 1. Okay, LHS side value will be what? 1. Now going with the coming back to the LHS side, here you have 1 square. 1 into 1, as we know. So 1 into 1 plus 1, guys, 1 plus 1, 2, right? 2 square by 4. So 2 square means what? 2 square means what? 2 into 2, 4. So therefore 4 gets cancelled, therefore we got what? 1. So as here I can say, therefore LHS side equal to RHS. Okay, LHS equal to RHS. As here LHS I got what? 1 will be the value for LHS. And RHS value is what? 1. So therefore I can say that S of 1 is true. Okay, S of 1 is true. Means as we have said what, n equal to 1, right? So by substituting, here we have substituted 1 in the place of n, right? So therefore I can say that where S of 1 is true. S of 1 is true. Absolutely true. Clear? Now let me go for the next one. The second case. Here we dealt with the first case. Let's go for the second case. The second case is what? S of k. The second case is what? S of k. Now guys, what happens here is, what you do is, in the second case mostly you assume that S of k is true. You assume that S of k is true, as here I am going to assume that S of k is true. Okay, assume that S of k is true, where S of k value, assume that S of k is true, means here instead of n value you replace k. Okay, instead of n value, what you do? You add k value. Okay, so what happens here? Well, this is the given equation where 1 cube plus 2 cube plus this is the given equation. Now instead of n value, what you do? You substitute k value. This becomes what? 1 cube plus 2 cube, 2 cube plus 3 cube, which goes on plus, here you will get 4k cube. Okay, instead of n I have substituted k, so that's what I can written, right? I have written like k cube. Okay, k cube. n square. Instead of n square, what do? I would write k square. K square into, instead of n, what you write k plus 1 whole square by 4. K plus 1 whole square by 4. Clear? Clear? K square into k plus 1 whole square by 4. Now guys, what you do is, here we got what? Here we got k square as it is, like k square instead of n square we got a k square into k plus 1 whole square by 4. So now guys, instead of n, I have substituted k value. So thus you consider this as first equation firstly, okay? The first equation, with this equation is very important to solve the given question. In the third case, we will be using this equation only. So now coming back to here, where guys here, where here we got what? As you can see, just observe the RHS set. Observe the RHS set, where this RHS set is some kind of equal to this side, okay? Where here you got k square, here you got n square, here you got k plus 1, here you got n plus 1 whole square. So therefore this both are equal. So therefore what would I say? Here where LHS is equal to RHS. Okay, here you have LHS, where here you have RHS. So LHS equal to RHS. So therefore I would say what? S of k is 2. Okay, S of k is what? Okay, this will be the second case. Clear? Now let me go for the third case over here. The third case will be, guys, it will do some kind of different one. So here what you do is to take the first equation, consider the first equation. The third case will be if S of k plus 1, okay, k plus 1 term. Third case will be k plus 1 term. So k plus first term or 1th term, where k plus 1th term is equal to k plus 1. As here we don't have any term, so what would I do? You just write k plus 1th term is equal to k plus 1. Okay, k plus 1th term is equal to k plus 1. Guys, here instead of n value, what you are going to do now? Instead of n value, substitute this k plus 1. Okay, instead of n value, substitute this k plus 1. So here in equation 1, what you do? Here I am going to add something, like I am going to write something, a point where adding here you have k plus 1, right? So k plus 1 is k plus 1 whole cube. Okay, so k plus 1 whole cube, k plus 1 cube. Adding k plus 1 whole cube on both sides. Okay, on both sides. In which equation? In equation number 1. Okay, adding k plus 1 on both sides in equation 1. We get what? By adding k plus 1 whole cube on both sides in this equation, we get what? So let's write down the equation. Let me form the equation over here. Okay, let's form the equation over here. Here I got what k cube as it is. Let this k cube be like that. Okay, this is the equation 1, right? So that's what I have written, k cube as it is. Here I have k plus 1 whole cube. Okay, let me go with k plus 1 whole cube, because here we have added k plus 1 whole cube on both the sides. Okay, in equation 1. So here you have what? The second one, the RHS side will be what? K square, k plus 1 whole square by 4. So now what you do? You add k plus 1 whole cube. So k plus 1 whole cube plus k plus 1 whole cube. Clear? K plus 1 whole cube. Now guys, what you do is here, you remember it like a very big remembrance. Like here you take this RHS side. Don't consider RHS side till we solve the RHS side, where RHS side should be equal to this RHS side. Okay, where this RHS side should be equal to this area, means to this value. Okay, so as here we have got what? K square into k plus 1 whole square by 4 plus k plus 1 whole cube. So what you do? You go like here, take LCM as 4. So here I am going to take LCM. So LCM I have taken here is what? 4. LCM into numerator by denominator. As here LCM numerator by denominator, this becomes what? K square into k plus 1 whole square. And here go with LCM numerator by denominator plus numerator is what? 4. 4 into k plus 1 whole cube. Clear? K plus 1 whole cube. Guys, here you see where k plus 1 whole cube I got. Here I got what? K plus 1 whole square. Don't k square and k square plus 4. Okay, don't consider that, but just look after this k plus 1 whole square, k plus 1 whole cube. Where guys, k plus 1 whole cube. Okay, k plus 1 whole cube, listen carefully. Where k plus 1 whole cube is equal to what? K plus 1 whole square into k plus 1. Right? This becomes what? K plus 1 whole cube. So here I have k plus 1 whole square, and here I also have k plus 1 whole square. So I am going to take k plus 1 whole square as common. Okay, I am going to take what? I am going to take k plus 1 whole square as common, as here I would get what? K plus 1 whole square. K plus 1 whole square as common. 4 over 3. So, clear? Now what you do? K plus 1 whole square we got common. Now here I got what? K plus 1 whole cube, right? So here what you do? You go for firstly k square plus 4. Okay, k square plus 4 as it is. K square plus 4 into k plus 1. Okay. Okay, here you have got well, k plus 1 whole square plus k square plus 4. K square, here I got k square, here I got plus 4, right? So that's what I have added, like k square plus 4. Okay, k square plus 4 as it is. And here k plus 1. Where here you have k plus 1, here you have k plus 1 whole square. So when k plus 1 into k plus 1 whole square, this becomes k plus 1 whole cube. So here you have k plus 1 whole square, k plus 1 whole square. Here you have k square plus 4, k square plus 4. This is what I have made it. Clear? Clear? Okay, let me write down the further step. Where should I write? Okay, I would write something from there. Let me write down the next step over here. Okay. 1 cube plus 2 cube plus. Okay, so here guys, next step goes like this here, where till here, no guys, what we do? 4 into k, 4 into 1. Okay, 4 into k, 4 into 1. So k plus 1 whole square. Okay, k plus 1 whole square plus here k square as it is. K square as it is. Now 4 into k, this gives what? Plus 4k, right? 4 into 1, this gives what? Plus 4. Clear? Plus 4k plus 1. As here you have what? That's all. K plus 1 whole square plus k square plus 4k plus 1. Clear? Clear till here? Now what you do guys here is, you go with this formula where a plus b whole square formula. A plus b whole square formula. Where by 4. Here you have k plus 1 whole square as it is. Let this square be like this. Okay, k plus 1 whole square as it is. Now here we have what? K square plus 4k plus 4. This becomes what? This becomes what? K square plus 4k plus 1. This becomes what? K plus 2 whole square. Okay, k plus 2 whole square by 4. Okay, k plus 2 whole square by 4. This becomes what? A plus b whole square, right? A plus b whole square is in the form of a square. A square means k square plus b square. B square means 4. Means 2 square. 2 into 2, 4. Plus 2 into a into b. So 2 value is what? 2 as it is. Right? 2 into k into 2. 2 into k into 2. This is equal to what? 4k. Are you getting it? 2 into k into 2. This becomes what? 4k. So that's what I have written like this. Okay, I have written this value as like this. Okay. Now guys, here we got what? K plus 1 whole square into k plus 2 whole square. Clear? Now as here, just make a look, like here just take a look. Here you have k plus 1 whole square. Here what I have said firstly? What I have said firstly, we'll consider n equal to k plus 1. Okay, n equal to k plus 1. So here n value is what? K plus 1. So here I got what? K plus 1 whole square. N square, k plus 1 whole square. Are you getting it? So this is what is n square I got into. Here you have k plus 2 whole square. Okay, k plus 2 whole square. So guys, here you have k, here you have plus 2. That's all. I got k plus 2. But I need what? K plus 1. So what you do? You go for another step, the extra step. So go with this. Here you have write k plus 1 whole square as it is. Now where k plus 2 can be written as? K plus 2 can be written as k plus 1 whole square. Are you getting it? K plus 2 can be written as K plus 1 plus 1. 1 plus 1 2, right? So K plus 2. So as here where K plus 1 is what? N value. So K plus 1 N plus 1 as this plus 1. Okay, plus 1 whole square by 4. So therefore this is in the form of where here this. Okay, this is in the form of this. This is in the form of this form where RHS said both were same. Here you have got RHS said and here you got what? LHS said. So therefore LHS said RHS. So we got this form, right? So therefore I can say what? Therefore I can say K plus 1 term. K plus 1 term. 1 term is 2. Clear? K plus 1 term is 2. Clear? Are you getting it?